Uh, Previously, we defined the determinant and derived a bunch of properties from it, or defined the properties and then derived other properties. And we showed how you could apply those properties. Now, I want to apply those properties to find other ways to calculate a determinant. The first way was basically like Gaussian elimination and using the properties that way. Let's build up. Let's start with a 1 by 1. Say A is this just a single element minus 3, 1 by 1. Two ways to look at it. One is I could pull out the minus 3 and I'm left with 1 in the matrix. And that's the identity matrix for 1 by 1. So A is just minus 3i. Well, the determinant of I is 1. So I get the determinant of this A is just minus 3, the element. Probably an easier way to look at it is this is a triangular matrix. It's only got one element, so that's the main diagonal, that one element. So that's the determinant. That's kind of a trivial, easy case. Let's move up to 2 by 2. We'll use property 3 to decompose it. We'll first look at this first one. Think of this as a vector A0. This is another vector 0b. You add them up, you have AB here. That means this determinant is the sum of these two determinants. Now I can break up each of these by doing the same thing with the second row. And I'll end up with these 4 determinants. But 2 of them, we'll look at it. A column of all zeros, another column of all zeros. Those determinants are 0. And I just have these 2 guys. I'll swap these 2 rows in this guy, so I have a minus sign there. So it's that determinant minus that determinant. They're both triangular now. So it's AD minus BC. We have a formula. Look at this guy. The product of the main diagonals minus the product of the off diagonals. Think of that X. And that is worth memorizing. Here's numerical examples. 4 minus 6 minus 2. 28 minus 6. 10 plus 6 is 16. 12 minus 12 is 0. That's worth memorizing. Let's move up one. First, I'll decompose this using the first row. So that's just that first decomposition. Then I'm going to decompose each of these. As I go all the way to the end, I'm going to have 27 determinants. I'm going to list them all here. But 21 of those 27 are going to have, they're going to be 0. They're probably going to have a column of all zeros in them. So I'm only left with 6 that might not be 0. And if you look at what those remaining surviving 6 are, they're all within a row swap of being diagonal. So I can calculate each of these determinants within, if I keep track of those signs, and you get a formula. This is a formula for calculating this guy's determinant. The point is not this formula, but that the properties lead to formulas. Now we're going to get into algorithms for actually making these computations. It's done differently than we already described. It's going to be called expanding by cofactors. And I'll save that for another video.